U.S. Department of Energy and contractor CH2M Hill Plateau Remediation Company, CHPRC, are reducing risks at the Hanford site in Washington State. In May 2017, workers stabilized a partially collapsed waste storage tunnel and prevented the potential release of contamination. The team is now poised to address a second tunnel that could potentially collapse. The tunnels supported the plutonium-uranium extraction plant known as PUREX. The facility is located in the 200 East area of the Hanford nuclear site. Scientists used a chemical process to extract plutonium from irradiated fuel rods at PUREX from 1956 to 1972 and again from 1983 to 1988. The PUREX design included a single 358-foot railroad burial tunnel, referred to as Tunnel 1. Tunnel 1 stored 8 rail cars containing contaminated equipment that was no longer operational and too radioactive to be disposed of elsewhere. Storing this equipment underground protects the workers and the environment. As Tunnel 1 neared capacity in 1965, workers built Tunnel 2 to maintain the operation of the PUREX facility. Tunnel 2 parallels Tunnel 1, is 1,688 feet long, and designed to resemble the shape of a Quonset hut, constructed of steel beams and shell with arched concrete supports and a concrete footing. Designed to contain 38 to 40 rail cars, it stores 28 rail cars containing contaminated equipment. 8 feet of soil berm covers the top of each tunnel to provide radiation shielding and to trap any contaminants should the tunnels collapse. On May 9, 2017, during routine surveillance, workers discovered a section of Tunnel 1 had partially collapsed. Engineers designed a safe and cost-effective long-term stabilization technique to address the tunnel partial collapse. Engineered grout successfully filled the voids surrounding the radiological hazards and secured the tunnel and its contents. CHPRC completed stabilizing Tunnel 1 in November of 2017. Following the collapse of Tunnel 1, experts conducted an engineering evaluation of Tunnel 2 and determined it is at high risk of collapsing. Its design does not meet current codes for structural integrity and may not bear the weight of the soil above the tunnel. Investigation of the tunnel confirmed corrosion at critical areas. The success and lessons learned on the Tunnel 1 stabilization project have been incorporated in the planning for Tunnel 2 stabilization and are anticipated to improve the project. Tunnel 2 has 17 riser ports with concrete plugs located at approximately 96-foot intervals the length of the tunnel. 6 of these ports will have the concrete plug removed and replaced with a specially designed insertion device for grout injection. Connected to these inserted devices will be a grout conveyance system, which then connects to the grout pumping system. The grout conveyance system provides workers the ability to connect and disconnect the pumping system at ground level, eliminating the hazard of performing work in an aerial lift and at elevated heights over the tunnel. All of the riser concrete plugs have a 3-inch steel observation port located within the center of the plug. This port is large enough to install additional lighting to optimize the functionality of the camera equipment, providing continuous monitoring the entire length of the tunnel during grouting. A passive ventilation system will filter the displaced tunnel air during grouting. This system utilizes HEPA filters and connects to a riser located on the north end of the tunnel. The engineered grout mix utilizes special additives that create the desired strength, high flowability, and self-leveling characteristics necessary to stabilize the tunnel. The mix, designed to flow up to 300 feet before setting, allows the grout to fill the tunnel and all the voids surrounding the contents in the tunnel, stabilizing the radiological hazards. The grout will be poured in lifts, a few inches at a time, with each lift curing before additional lifts are poured. This helps secure the contents of the tunnel as engineered grout is added. Once complete, approximately 5,000 truckloads of engineered grout will fill the inside of PUREX Tunnel 2. Grouting PUREX Tunnel 2 will prevent potential failure of the tunnel, provide additional shielding against radiation, and control contamination to ensure the protection of human health and the environment, while not precluding final closure and cleanup decisions.